In this video, I'll be explaining how changes in flux leads to production of EMF. In this question, they have asked that flux will be varied as shown in the graph, and we need to find the graph of ERS. So there are two methods for solving this question. First method is by going through the options. We can select the options which is closer to the solution. And the other method is the typical calculation. For both of these methods, we should know two formulas, that is Faraday's law of induction and also Lenz's law. So Faraday's laws of induction motion states that an EMF is induced in the coil when a coil experiences change in flux. That means if a coil is having n number of turns, then the EMF induced will be the product of number of turns into change in flux with respect to time. This is the Faraday's law. Now the next law we should be knowing is Lenz's law, which states the induced EMF opposites its cause. That means for an induced EMF, the cause is change in flux, and according to the law, it opposes. That means there is a negative direction between E and d phi by dt. Then again, according to Faraday's law, the formula will be this. This is the most important formula, and this formula is used in many places. Based on this, we are going to solve this question. If we take a look at the waveform of flux, now let us separate the waveform into three regions. That is region number 1, region number 2, and region number 3. In region 1, what we can say is there is a positive slope of flux. That means if time is increasing, flux is also increasing. That means d phi by dt, which is slope of the line, is positive. Similarly, in region 2, we can see that the flux is not changing. That means change in flux with respect to time is 0. Again, d phi by dt is 0. In region 3, we can see that flux is decreasing with increase in time. That means again d phi by dt is negative. Now let us see the variation of EMF with respect to flux. We saw that the equation of EMF is minus n times d phi by dt. So here d phi by dt is positive, here it is 0, here it is negative. And in that case, E is equal to minus of positive slope. Here it will be minus of 0. Similarly, here it will be minus of negative slope. Finally, we get EMF as minus 0 and plus. That means EMF will be negative in region 1, 0 in region 2, similarly positive in region 3. Now if you look at the options, we can see that EMF is 0 in every region 2. Now let us check for region 1. EMF should be negative in region 1. So in that case, option number A and C can be ruled out. Now the region number 3, that should be positive. In that case, we can also rule out option number D. So our correct option should be B. But here we will also see method 2, because just in case if there are more options similar to this, we will get confused. So option 2 will be mathematical. So for that, here also we should know the formula of EMF, that is minus n d phi by dt. And remember, in the question they have asked for EMF across the secondary winding, that is ERS. That means we are using 200 as n because secondary is having 200 turns. And also remember this waveform, ERS is having 200 number of turns. So now in region 1, d phi by dt, that is change in flux with respect to time, is 0.12 minus 0 because that is from origin, and 1 second minus 0, that is also origin. So that should bring us 0.12 in region 1. Again, in region 2, d5 by dt, you can see that there is no change in flux. That is only 0.12. Hence, 0.12 minus 0.12 divided by 2 minus 1. This step is actually not required, but still we have d5 by dt as 0. Similarly, in region number 3, we have d5 by dt as 0.12 minus 0 divided by 2.5 divided by 2. That should be 0.12 upon 0.5. But do check this line, it is negative. It is falling from 0.12 to 0, hence the slope will be negative. This can be written as 12 by 50. Now we know all the d5 by dt in region 1. We shall calculate the value of EMF. EMF is minus of 200 0.12 in a region 1. That should be minus 24. Similarly, E in region 2 is 0 times 200 is 0. Similarly, E is equals to minus 200 into 12 by 50. That should be 48. No need to actually draw the waveform, but still I will draw so that you get a better understanding on how this waveform came. EMF is minus 24 from 0 to 1, 0 from 1 to 2, and plus 48 from 2 to 2.5. So our answer should be B. See you guys in the next one.